Hello, hello, hello. Welcome to today's webinar. I'm really excited about this topic and thank you all for coming. Today, we are going to be talking about .NET DevOps architecture when using TeamCity Cloud. And we'll talk a little bit about what TeamCity Cloud Edition is and how it differs from past versions of TeamCity. But we're also going to talk about the important architecture piece, which is so important, which drives every implementation of any tool that we might use in our overall software engineering or DevOps process. So we have a lot of information. Let's get into it. And I'll start out just for those of you who came just by way of JetBrains and are getting to know ClearMeasure for the first time. We are a US-based software architecture company that empowers software development. And our goal is to make your software team highly effective so that you can move fast and increase quality. So clearmeasure.com is our website. And we are focused on the Microsoft development environment and the Microsoft development ecosystem and all of the tools and technologies that surround that. And so JetBrains is a huge part of support for C# and .NET. A little bit about myself. I have dirt biking as my hobby, and we live just far enough out in the country to the west of Austin, Texas, to do a little bit of light ranching. And so just thought I'd throw that in. Now, when we get into TeamCity, there's a long history there. This is a blog post on my blog from 2007 when TeamCity just came out with the version that started to support .NET because the first version supported Java and some other technologies, but TeamCity 1.2 started developing .NET, and then the product got better and better and better. And then by 2009, for myself personally and all client recommendations and business work, I've been steadily using TeamCity since 2009. And even as new products have come on the market and I've helped out clients with those products, I've had multiple clients with very significant TeamCity installations the entire time since then. And so a long history with TeamCity, long history with a partnership with JetBrains and ClearMeasure, and going back to 2015 on the JetBrains company blog. There's one article, and then in 2016 we did a joint webinar on continuous delivery with TeamCity at the helm, and so you can find those things on the JetBrains website itself. And then also, if you're a subscriber to Code Magazine, which if you have a Visual Studio subscription, which probably everybody here does, except the executives in attendance, you already have access to a complimentary version of Code Magazine if you just take advantage of the perk. But anyway, in the 2006 edition, I wrote an article on DevOps and continuous delivery, and you have to pick a few technologies to illustrate any kind of points, and so TeamCity was featured in this article. And in 2019, I wrote a DevOps book for .NET, and you can find that online. And even as tooling comes and goes, the concepts and the strategy is the same. So even if you're seeing some old tooling, you can read the first half of every chapter, and it's timeless material. But if you just send me an email at jeffrey@clearmeasure.com, I'll be happy to send you an electronic copy of the book. All right. And then, just so you know where we are coming from, ClearMeasure has a methodology. We call it the ClearMeasure way for effective software teams, because we believe that when equipped and trained properly, every team can be successful. And so our purpose, our goal in that is to simplify and synthesize known practices, but in a manner that any software team can implement. So we push hard on that front. Now, I'm going to get into TeamCity and the differences in the Cloud Edition, and we'll dive in and I'll show you all the settings that you need. I'm going to go into deep detail here, okay? And I'm also going to give you tools for going back and say, wait a minute, you're going too fast. But I have a quick poll just before we get into it so that we can understand just kind of the breakdown of who we have on the webinar. So if you wouldn't mind just quickly checking a few boxes there on the poll that's popped up, and I'm curious as to what versions of .NET that you happen to be using and what your primary role is. And you should see that poll up on the screen there. And got some responses coming in. That's fantastic. All right, and as we go forward, TeamCity's been around for a long time and has long been the leader in continuous integration build servers and just build servers in general. And so when we think about what position TeamCity has, it's had a very strong position as a build server. It's probably the most complete build server product out there on the market. It really supports any technology that's out there. Even along the way, Microsoft did a big push with converting team services to Azure DevOps in 2018-19, and then with the acquisition of GitHub and pushing on GitHub Actions, and they're investing heavily in that. However, just from a feature set and capability perspective, they've got a long way to go to catch up with what TeamCity has already accomplished. And one of the big strengths that Microsoft was faster to market on the cloud front is hosted instances or hosted agents, where you don't have to manage the operating systems for any of your build server agents. And so Microsoft beat TeamCity, just candidly beat TeamCity to the cloud hosted configuration. However, TeamCity has the cloud configuration now. So when you compare other products, TeamCity just objectively is best of breed, is the most complete offering out there. And so if you haven't tried TeamCity before, there's a 14-day trial, and then for any development team, it's very affordable, $45 per month, which is less than any development team spends on anything. So very, very approachable pricing. And of course, if you want to just run it locally, install it on your computer, you can get TeamCity Professional and just use it with literally no cost. So that's the product. And it is huge to be able to just click on a form and automatically have a build server provision for you in the cloud along with build agents. So let me just move on from there. All right. The Slash Data and Continuous Delivery Foundation have done just this year another State of Continuous Delivery report. I thought a few of the elements would be interesting to this crowd. And we shared some of this on the joint webinar that we also did with Octopus Deploy, which also partners very heavily with TeamCity, and those products work really well together, and you'll see a DevOps environment with that as a combination. But one of the questions is what do you use? What is the usage rate of self-hosted CI/CD tools versus cloud-hosted? And one of the findings is that people are moving to cloud-hosted CI/CD tools, and that has been a significant decrease. So the light blue is 2022, and the darker blue is 2023. And so the most popular self-hosted tools have been TeamCity, Jenkins, Hudson. But even in those, people are moving to the cloud-hosted version in general. So that's interesting because it's a big industry trend. Also, they found that people who used CI/CD tools in general are significantly less likely to be low performers than those who don't. They analyzed the lead time for code change on the left, which the people who are using CI/CD, those are the green bar charts. So lower lead time. And then the deployment frequency is higher at least once a week to once per month, and many once per hour to once a week, and about 11% multiple deploys per day. And then, of course, time to restore services when you have an issue in production. That's also dramatically improved for teams that are using CI/CD tools. And I may be preaching to the choir with this particular crowd, but I thought that was interesting. So let's kind of start digging in because we have a lot to cover. And every bit of what I'm going to show you, you can have for free. The links here on the screen, do some screen capture. I'm also going to just kind of leave this up for a little as I talk through it. But the GitHub account, github.com/clearmeasurelabs, this contains a Git repository of a complete reference implementation of a .NET application with a completely automated DevOps pipeline powered by TeamCity and Octopus Deploy. The environments, as 3 different environments. The environments are in Azure, and it's simple. It's using an Azure container app. So it's a containerized web application. It happens to be a Blazor WebAssembly application, and a Azure SQL database, albeit tiny database. However, when you're developing .NET applications, now there's a good chunk of WPF and Maui and WinForms as well, but almost everybody who does .NET applications has at least one application that has a web application component of some type and a SQL Server database. Now, there's other backend jobs and all kinds of other things, but everybody has at least those. That's just the way it is. And so when it comes to a reference architecture, that's what everybody has. And so to illustrate this, that's what we've chosen. We didn't choose just a web application where building a deployment is just copying files. We also put the database in there because that tends to be tricky and people have issues with it. The second URL is also is actually the production environment we have for this reference implementation, and it's live and online, and I'll show it to you here in a second. And then the TeamCity build server, you can go to clearmeasure.teamcity.com/registeruser.html, and we have configured it so that all of you can create a guest account and automatically have a read-only account to this particular instance and this particular project so that you can see this for yourself on our TeamCity server. So you can get in there and look at it. Also, as you poke through it, and I'm going to switch screens just for a second and pull over the browser. And this is the GitHub repository, and you'll notice that, and I'm going to go into some of the the build script down here in a little bit. You have some getting started information, but you'll notice there's a .teamcity directory. Okay, so we have the actual configuration as code for TeamCity in this particular repository, and that's important, as I'll show you in a minute. We have the Octopus Deploy project, which I'm not going to go into, but just so you know, it's there because TeamCity is a build server and it doesn't have the feature set of Octopus Deploy for deploying and managing environments, but it is the brain to orchestrate the pipeline, as we'll see. But just so you know, it's integrated with Octopus Deploy and Azure. This is the Azure Container app, and we can click on the containers. It's just one container, and the image tag is the version of what was just deployed to production, 3.0.186. And as we go along, we just create a revision. Now, I'm not going to go into how Azure container apps work or Docker if you've never used it before, but just know that's the Azure resource, and then it's talking to an Azure SQL database behind the scenes, which we're not going to go much in depth. And then here is the actual application. Very simple, and it's an application, and we have a simple SQL Server database behind the scenes for the new page. Okay. All right. So as we go through here, we'll get into all the details of TeamCity. This is TeamCity Cloud Edition. This is this project, and we can see the different build configurations that make up our DevOps pipeline. And I'm going to go through these, and I love this I love this dashboard because the gray lines on the bottom show how long the build had to wait in the queue before starting, and the green line on top showed how long the build actually took to complete. So we can see maybe over here, it took a little bit longer in the queue, 18 minutes. But you can see the runtime is pretty consistent. Building this particular application, all in all, takes 6 minutes and 40 seconds. Deploying to the first environment, which we call the TDD environment, generally takes around 13 minutes because, and I'll show you, we are creating our test automation environment in Azure from scratch, kicked off from TeamCity with Azure ARM templates, and then we're destroying it. See this delete TDD build. We're destroying it after the fact in parallel with deployments to a manual UAT environment and a production environment. So TeamCity has a lot of power to orchestrate everything that you might want in an automated DevOps pipeline. Okay. So briefly, I also want to show you the Visual Studio solution that this application is. Boom, right there. Okay. Blazor application is there. This happens to be the build script, which I'll come back to. But if I go to ReSharper and architecture, show project dependency diagram, along with TeamCity, I also love ReSharper. Been using ReSharper since 2013, integrating with Visual Studio. This is the structure of the application. It happens to use the onion architecture method for managing dependencies. If you've never heard of onion architecture, just give it a Google search. And the 2009 article on my blog, jeffreypalermo.com, is up there describing onion architecture. And so the core project, which is literally just a library, is right here. It doesn't really have any references. It is just code, okay? And so we want to keep most of our business logic and model objects in a library that doesn't have a whole lot of tentacles to all these other libraries that our application might need to use. Those are in interface projects. And of course, data access is an interface project into a data storage dependency. UI.client is an interface into the user, of course. It's an interface over to the user. And then we have unit tests, which of course depend on the core project to exercise that capability. And then UI.API, well, then it's in the name, application programming interface. It's an interface into web services. And then we have UI.server, which just starts up the application. So by its nature, it has to depend on these other things to wire up the services collection. Then we have integration tests that exercise more things collectively across interfaces, and then full system acceptance tests, which actually run in a fully deployed environment, which I'll show you. And then our database project kind of sits over to the side because it's not really a .NET project or assembly. It's just a holder for database scripts. Because as we deploy, if we add a column or add a table, we need a SQL script to run. So it uses AliSQL as the database migration tool. And as you'll see in the build configuration, it kind of packages up all of this, including the ARM template for creating the database in Azure. And it also has a PowerShell file to run the appropriate command along with parameters to actually migrate the database. So everything is here, and we'll come back to the build script. But if I'll just say, if your applications do not have a PowerShell build script, just go to this GitHub repository, steal this build script, and just modify it. You do not need to invent your own build script from scratch. I'll just show you one example of why. Even to compile, do you want to go and figure out exactly what combination of command line switches are generally appropriate for most applications? No, it's already been, other people before have already figured this out. This build script, I think, goes back to at least 2005. And I know from there, a lot of the patterns came from somebody on that team who worked on the Windows team at Microsoft, and said that some of those patterns he learned in the mid-90s when they were doing C and C++ make files. So the legacy of this particular build script template goes way back, and a lot of people have contributed to making it better and better and more general purpose. And most of the things that you have to change to adapt it to your own application have been pulled up to simple variables at the top. Okay, so this particular build script template, if you just search for snippets of it, you'll see it all over the web because so many different people have used different versions of it. Don't start from scratch. Just go and grab this and modify it for your own situation. Please save some time. Okay, so let's keep going. I actually showed you this interactively, and that's good. So let's talk about DevOps architecture, because I want to show you every setting of TeamCity and the build configuration and how to chain builds together to make an entire DevOps pipeline. But I want to make it clear what we're going for here. What we're going for here is an environment where changes can flow all the way through to production. And so we have a place where we work on code, and then we have the build server kind of at the front, watching the code repository, whether it's a feature branch or whether it's the master branch or the main branch, and kicking off the first build. Okay, so the TeamCity, the build agents, they jump into action and run and spin up automatically, and then they produce a release candidate. A release candidate is a set of deployable packages. And of course, in the .NET world, this means they're NuGet packages. Can you use zip files? Yes, but NuGet packages are just so good and so easy to use. So we like using NuGet packages, which essentially are zip files with just a little bit of variation. So we produce NuGet packages that are our release candidate, one NuGet package for the web application, one NuGet package for the database, one NuGet package for our full system acceptance tests, but together they are one release candidate because they have the same version number, okay? And then we put them in a NuGet server. Well, lo and behold, TeamCity has a built-in NuGet server. Now, if you already have a different internal NuGet server, and if you've offloaded that, by all means, use your NuGet server. And of course, you have tons of options for where you might want the NuGet server to be. But unless you've already created another NuGet server, then just put in a ticket and ask JetBrains to enable the NuGet hosting on your cloud instance, and you're off to the races. All right. So now that we have a release candidate, the next step is to deploy. Now, remember, if you've never read the actual book on continuous integration, go read it. It was written in 2006. What is that? 17 years ago. Okay. But it's still, the pattern has held true. The book is literally called Continuous Integration, published in 2006. And even the 2009 book entitled Continuous Delivery didn't redefine continuous integration. It just added on deployment patterns. So the continuous integration book, way back when the pattern was defined, after 6 or 8 years of the industry kind of haggling and arguing and sharing at conferences on what it is and how to do it properly, we've got 3 key stages defined when it comes to continuous integration. The first stage is your private build, called the commit stage in the book. And your private build actually runs without any build server. It runs on the engineer's workstation. And that's why you need a private build script. That's why you need a build script to power your private build locally. So locally, we create the database schema. Locally, we do compilation. Locally, we run unit tests and integration tests and whatever checks you can fit on the local machine in a reasonable period of time. And that's the private build. Then you know that it's healthy to actually share the code with the team. Because if you broke something, it's just a waste to even push it up and share it with your team. So you share it with your team, whether it be a direct commit on master or whether it's a pull request of your feature branch. And then the integration build kicks off. That's the second stage of continuous integration. And the build server is the brain that kind of kicks in and says, oh, it's something for me to do. And so that build script that powers your private build, it is the core, the nucleus of your integration build as well. And your integration build is going to have additional steps, but it's going to have the same steps as what your private build has. So that's why every application needs some sort of build script, because they're shared between the private build and the integration build. And so that's the integration stage. And then the third stage of continuous integration is the first deployment. We don't know that we have successfully integrated new changes unless we actually put the application on a production-like environment and actually start it up and actually exercise it and make sure it still generally works. Not exhaustive testing, but just make sure it generally works. That's the third stage of continuous integration. So when you're thinking about your own implementation of continuous integration, ask yourself, do we have those three stages? From the time that continuous integration was coined as a pattern, those are the three stages. So it's important that you have those. The third stage of deploying to a production-like environment, that's what we represent here. We like to call it the TDD environment. Some people call it a dev environment. But either way, it's an environment where we do not do manual testing on it. It only exists to be created, have a new release candidate deployed to it, run some types of checks to make sure that the application generally works and starts up appropriately, and then destroy the environment. Now we have a release candidate that we have some confidence in, can progress to another environment. Of course, the next natural stage is to put it on an environment where somebody can do some manual testing. And then after that, we, at some point push it out to our customers, hopefully very soon. And so TeamCity's role in that is to orchestrate that process. And one of the pieces of orchestration is to integrate with Octopus Deploy, our automated deployment tool, to do the configuration into Azure or whatever our environment is, get the application stood up. And then when it finishes, especially in our TDD environment, our test automation environment, then TeamCity, again, a build server technology, runs automated tests. And we'll see, I'll show that to you, running automated tests against the release candidate of our application that was just deployed to our test automation environment. All right, so there's a lot more information on this DevOps architecture diagram. We have this in a large format, a DevOps architecture poster. If you do not have already from previous webinars and talks, a high resolution copy of our large format DevOps architecture poster, then just send me an email and I'd be happy to send it over to you. And you can take it to a print shop and get it printed out. And actually, you can't see it quite a bit, but that poster behind me, if you see the camera, that is a fully printed out architecture poster. Okay, and my email has been added in the chat. So there we go. All right. And I think we answered a question in the Q&A. Can you share the sheet to read it carefully, please? Yep, a lot of small text on that. Send me an email. I'll send you the high resolution copy of that architecture poster so you can see all the text. And then there was another question. Was the TDD stage the same as stage 3 or after stage 3? Yeah, good question. The TDD environment is the place where we deploy in order to fulfill stage 3 of continuous integration. Okay, because the first deployment stage of continuous integration at stage 3, that is deploying it somewhere that is similar enough to production where we believe that if it'll break in production, it'll also break here, and then run some type of tests. And that answers two questions. One is, will it still deploy with the changes that we just made? And does it still start up with the changes that we just made? And so oftentimes you don't just load up the home page, you at least need to go to a few pages and maybe click a few buttons and do something to truly answer for yourself. Yes, okay, it still started up properly, it still generally works. And you can springboard off of that beyond continuous integration to create some more exhaustive full system acceptance tests. So that's your springboard for additional test suites that require an instance of the application that is fully deployed on a representative environment. All right. So thanks for those questions. Those are good. I'm sure other people have the same questions. Now, one other guide, because I'm about to jump into lots of nitty-gritty details. We have a rather deep document that is a step-by-step guide to implementing this exact application and this exact pipeline configuration with TeamCity Cloud Edition. So if you are not already using TeamCity Professional or Enterprise, if you would like that document, again, just send me an email, I'll send it to you. And it'll show you how to build this exact pipeline, because I know you're not going to get everything with just me showing it. Okay, so we've written it up, and we do this, we help our clients through this implementation as well, because regardless of the type of architecture and the different flavors, yes, there's going to be more components, but this is the architecture of the automated DevOps environment. Everything else is just additive on top. And so this architecture gives you automated deployments, automated unit testing, automated integration testing, automated full system acceptance testing. It gives you measuring of code coverage. It gives you a versioned pipeline. So from the first integration build all the way to production deployment, you have traceability of that version number, and you know exactly what version everything is. You get release candidate packaging and deployments and repeated deployments. You get infrastructure as code automation, so that we can create the environment for this application, which is Azure Container Apps and Azure SQL, create it automatically just by plugging in your own Azure subscription. It gives you an example of a containerized application as a Docker image. It gives you approval gates for the higher environments. Definitely you want to have an approve button for production. It gives you a post-deploy health check pattern to be able to ask your application a more deep question. Are you actually healthy? So that you have IT monitoring tools that don't just check to see if the homepage is online, but can go to a web service endpoint, which actually tickles all of the dependencies, making sure everything about the application is online. And then this also gives you a pattern for automated database migrations with SQL Server. So a lot is packed into this pipeline, and we're only scratching the surface because we're focusing on the role of TeamCity in this environment. So send me an email if you'd like that full, implementation guide. Okay, so let's get into the configuration. There are some constraints when using TeamCity for a DevOps pipeline, and you want to use one versioned application for your Git repository. Some of the older version control systems, the centralized systems like Subversion and TeamCity, allowed an entire directory tree, and people put all kinds of applications and in different, what looked like subdirectories. But if you've migrated from that to a Git repository, and your Git repository looks like a massive network share with tons of applications, you're going to need to do some work on that in order to unleash the power of TeamCity when it comes to shepherding your DevOps pipeline. So I just want to hit up that point. This is a graphical depiction of what the structure of your build steps should look like. And of course, we need the PowerShell build script, because you can see the similarity in the private build and the continuous integration build, which you can call it CI build, but the official term is integration build. You have private build and you have an integration build, because those are two stages of the overall continuous integration pattern. But a build is just a larger order of tests. So if you've ever done test-driven development, red, green refactor, or arrange, act, assert, a build is a test. You do some things to set up, you do some things to arrange, then you do some things, the act part, you actually do the compilation and linking everything together. Then you have assert. Now we check some things to make sure that we're good. So arrange, act, assert. It's the same thing when it comes to a build. A build structurally is just like a test. And so we are going to clean past temporary files. We are going to stamp it with a version number. We are going to set up the database. You see the migrate database, because in order to do our asserts, we actually have to have a database online, because it is a dependency that the application has for storing and retrieving data. Whatever dependencies your application has in your architecture, you need to set up that dependency so that you can properly do a build that has any hope of running component level integration tests that bridge the code that pokes into those dependencies. And then of course in the act is compiling. I mean, with .NET it's pretty simple. .NET.exe build with some command lines, and then we run our unit tests, and then we run our integration tests. Then we do additional things in our integration build. We might add static code analysis. That's always a good idea. And we will publish the test results. We will package up each deployable piece of the application in a deployable package. And then we will publish those packages, which make up our release candidate. We'll publish it to our NuGet server. So that's the structure of a build. Now, when it comes to the process by which we finish continuous integration, this kind of finishes continuous integration with our pull request. So and this goes more sequentially. Developer is going to change some code, run the private build, then is going to do a git commit. The build server is going to spin up on the feature branch and create a release candidate off the feature branch. Now these are beta, alpha release candidates. Those are, if it's built from a feature branch, it's never going to go to production, but it needs to go to our first line test automation environment because we need to know that what we just did still deploys and still starts up. And so we will deploy it. Then we will run however many full system automated acceptance tests we have. Then we know that whatever I did on my feature branch was good, and I can create a pull request. And then with my team's pull request inspection checklist, I can ask one of my team members, hey, would you check out my pull request? Yeah, that's how we tend to talk to team members in Texas. And then team member goes through the checklist. Of course, if there's any feedback, but all good. Click merge, and now we merge it onto the master branch. And then the build kicks in again because now there's a change on the master branch. And then we deploy a release candidate, and then the full system acceptance test run again. And now we actually have a potential GA or generally available release candidate that can go further on to manual test environments and then on to production. So that's how this works. And I think I already showed you this, but Octopus Deploy is integrated with this version of TeamCity. That's very important. All right, now let's dive into this. This is graphically what our TeamCity pipeline looks like. And right from here, I'll pull up the actual TeamCity configuration and we'll go through it. But you can see our integration build happens first. Then right after that, we have a stage in the middle that just has to be there because technically we are running it on a different operating system. Now, this happens to be the cause of this happens to be because this reference implementation chose to use Azure Container Apps with Docker, and so our build server, the agent that we've chose is a Windows build server because we have some tooling that just is Windows tooling, right? Not all of the tooling in even .NET 7 has migrated to where it literally doesn't matter what version you use and you can go on Linux. So that's that. And so the Docker build and push is running on a Linux agent, whereas integration build is running on a Windows agent. And so we're containerizing our application there and then pushing it onto the TDD environment. So you can see on each stage, we have 21 tests that ran in the integration build. Again, this is a tiny application. So this is a reference implementation. So we have 21 tests between the unit tests and the integration tests. And then in our fully deployed environment, we deploy it, and then we've run 4 full system tests, okay? And then going forward, we have 2 builds that run in parallel. We have one that's called delete TDD, because with this configuration, after we've run it, we don't need the TDD environment to stick around in Azure running up our bill. It's just not necessary because when we do something on a feature branch, we're going to spin up a temporary TDD environment, we're going to run the tests, and we're going to destroy it. And with parameterization, with the build number, and then parameterization for the URLs in Azure as we create it, and database names, we can have any number of feature branches being actively worked on by as many developers as we have going, and all of this will be parallelized, and our TDD environment will be automatically parallelized just depending on how many builds are running on how many feature branches. So that's a really strong capability of this technique, and TeamCity handles it flawlessly. And so we're going to delete the TDD environment after it's done. And then the UAT environment, user acceptance testing, that's a manual test environment. So we'll deploy there, and that has a approval gate, which I'll show you. And then off of there, we go to production. And then there's something at the end that I'll show you that kind of makes sure that the delete TDD environment actually finishes in production, so that we know we don't have anything hanging out. Because if this, for some reason, we go to production, but the delete TDD environment fails, then we might have Azure resources that are sitting around running up our bill. And so we kind of have a termination step at the end, which I'll show you. All right, so let's go under the hood and look at this. Okay, so have this right here. Let me just kind of full screen this for you guys. And let's look at, actually, I'm going to go straight into the integration build. Now, in TeamCity, if you're not on Cloud Edition or not on a recent version, there is a UI that you might be used to, and this UI has been pretty consistent going back to 2007. And so we're going to click on the Sakura UI, which is the latest. Okay. Here we go. All right, so just so you know that, and if you hit S, now with Resharp or JetBrains has always been great at shortcuts. If I hit the S key now, sidebar closes. If I hit it again, it opens. Now, if I want to search for something, I hit Q, and now I'm immediately jumping there where I can look at a different build, and I just hit enter, and it automatically goes there. Okay, so I really love that aspect. Let's go to project settings. I'm just going to edit the project because I want to show you how this is put together. Now we're going to get into the weeds, and your eyes are going to glaze over a little bit. We have to go fast, but we have our step-by-step guide. So in the project, we kind of set some high-level settings, like what is the Git repository for our version control system root, and it's set to be there. Okay. We also enable a reports tab for code coverage. That's important, as you'll see. We also have a lot of parameters, and you can see some of these are for Octopus deploy so that they're available. And here's the settings. Some of them are credentials that have one-way encryption so that I can't even get this back. Okay, that's important for security. It's not stored in config as code in GitHub. And we have some UI patterns for the TDD app name to add on to. And then a build number. We have some of our scripting that looks for the build number in environment variables, and so we can put any kind of variables in environment variables there. And so those are variables. Now let me switch over real quickly to GitHub, because GitHub has a .teamcity directory, and these are settings. So settings.kotlin KTS, you can see that this is literally Kotlin code, and look at that. Those are parameters. If I make a change here and commit to the Git repository, then TeamCity is going to synchronize that. If I make a change in the TeamCity UI, it's going to make a commit to the GitHub repository. So that's super important. All right. And by the way, you can compare and contrast, because this particular GitHub repository also has a equivalent build for GitHub Actions, and also an equivalent build for Azure Pipelines. And so you can see firsthand why I say that TeamCity is the more complete build server, and why the competition just has a ways to catch up. All right. And then connections. These are things that you have to connect. So if we're going to push an image to the Azure Container Registry, then we have to have that connection to Azure. TeamCity speaks the language of Azure. It is no drama whatsoever. Okay, so that's great. And then our NuGet feed. So we've enabled NuGet. We have a feed. We've created it here. If you want 2 NuGet feeds, go for it. All right. So that is the root. That is the root settings that every one of these builds just automatically inherits. So it doesn't have to be redefined in each build. If I go to the configuration of this particular build, the integration build, I can see in version control settings that it just inherits the VCS root, no big deal. And then there's 3 build steps. There is one that is setting up the environment. So the build agent, just hot off the presses, the Windows build agents for TeamCity Cloud now include SQL Server Express automatically enabled there. And we just haven't refactored this reference implementation yet. And so without that, we just have some command lines that install MS SQL local DB, and we enable that. And now we have a SQL Server database engine ready to go for the build. Okay, but just want to let you know that. And then the second step is running our build script and running the CI build task, which I'll show you. And then the next is publishing the packages that are produced, the release candidate packages, to NuGet. And this is a good time to jump into build.ps1, because at the bottom, we're actually calling CI build, which does what? Well, it does init, which cleans up temporary files. Then it runs the compile task. Then it runs our unit tests. Then it creates our database schema so that our integration tests that depend on entity framework and the database being there work. And then we package our steps. And so I'm not going to go through every aspect in here, but we can see package goes through all the different things that need to be packaged. And you can see package UI. Well, it's .NET.exe publish with all these magic command lines. And then we're actually using a .NET Octo tool from Octopus Deploy integrated with .NET.exe, and we're actually packaging it up. .NET 8 has some super promising stuff where they're going to enhance packaging for not only NuGet but also Docker containers. So I expect some of this to be even further simplified with the .NET 8 timeframe. All right, so those are the build steps. And you see, if you don't have a build script of your application, then one, you don't have a private build, and so you don't have the first stage of continuous integration. And two, you're going to be having to manage every single step right here, and so a lot of that logic just really goes well in PowerShell. It just really does. Okay. All right, build features. XML report processing for our tests. We definitely want to have our tests being processed. I already showed you some parameters. We inherit, show inherited parameters, boom, there. These are all of the parameters that we've inherited from the project. We can add build only parameters if we want to, but we don't need to. All right, so that's the integration build. Now, what happens next? Well, I'm going to go Q, and it pops up. And I'm going to just use my arrows. So I'm going to go to Docker build and push, just because it's next in the stage, because I need to containerize one of these, which is the web application. And so if we go to our configuration in here, the dependencies is what creates a build chain. In the second one, I have a snapshot dependency on integration build. That means any of the parameter settings, the build number, everything that was true when this particular integration build ran for 3.0.186, TeamCity snapshots all of those settings so that this build can run with all of those same settings and you can count on it. So that's what snapshot dependency is. Artifact dependency is that the files you declare as the artifacts from the previous chain, they end up being the working directory of this particular build. So rather than this build checking out the Git source and the Git source being its working directory, the artifacts that were declared in integration build are the working copy of this that it operates on. So our build directory that all the NuGet packages are there, that becomes the working directory so that our build steps work. We just a little bit of tooling. We need to install a NuGet tool. Then we build the Docker container, and just to show you a little bit about that, there is a Docker file in here, and look what we're doing. We're literally giving it an image and a tag name right there, and that's pretty much it. If I go to the next step, which is Docker push, let's show those settings. Then again, Docker command push, and we are taking the image name and the tag and pushing it to our repository, which has already been established higher up in the project. So there's advanced settings. We don't need them. This is literally all that's necessary. Okay. All right. And you can always get to the other steps. Just all these little niceties that have been built up over time in TeamCity. Okay. Now let's go all the way to the end. Let's see here. No, don't need to save that. Let's go all the way to the end to this last one, which is deploy application. So if I go to deploy application and go to dependencies, I see that it depends on prod and it depends on delete TDD. That's how our pipeline comes to the end. Now, it doesn't matter what you call this. If you have a pipeline that branches out so that you have some different stages that run in parallel, you want to have a concluding stage just to bring those back together so that you don't think that you finished the entire pipeline if one of those branching stages actually had a problem. So this doesn't have any steps except for to bring these together. And because this is the build configuration that's at the end of the pipeline, it is the one that actually has the VCS trigger. And because this has a dependency on the previous one, it tells the previous steps, hey, I need you guys to run because I need to run. And then those previous steps have a dependency on the one before. And so they tell the previous build, hey, I need you to run because I need to run. And then it gets all the way back to the integration build. So all of these don't have to have a VCS trigger, only the build at the very end of the pipeline. So that's just, that's how TeamCity creates DevOps pipelines, which is called build change. It is by build configurations having a dependency on the build configuration that came right before it. Okay. I do want to show you one other thing here in production, and that is a build feature, build approval. All right. If you want just not anybody to be able to deploy to production, then you can specify approval rules. Now, with this being an example, we're just saying, you know what? You got to be a user here, but you can specify a different group. And here's how you control which users can do. And TeamCity has integration with other ID providers. So everybody doesn't have to have TeamCity usernames and passwords. You can integrate other ID providers in here. All right. So let's go ahead and cancel that. And I do want to show you the build step here in production, because we're going to deploy to prod. And literally all we're doing here, production should be the least amount of drama. And all we're doing is using a built-in Octopus deploy step to deploy to release, and the parameters that we've specified. What's the URL to Octopus? What's the space name? What's the project? What's the build number that we're going to deploy? We have a timeout. If it takes more than 30 minutes, I know something went wrong. Okay, so that is super simple. Now let's go to the TDD environment. TDD environment is different. So notice how if I go on the build change for TDD, let me just open this up, and I can see we have 4 tests that run. And of course, this is a different view, but this is kind of the same concept. So let me go to edit configuration and the build steps. Now we have several more build steps. We're actually creating and deploying the release with Octopus deploy, which is just telling Octopus deploy not to deploy, but to actually create the release. And we can change the runner. We can set the same steps. We can specify what environment it goes to. And then, of course, we have the checkbox, show deployment progress. So every bit of the logs makes its way into TeamCity. All right, let's keep on going back to the other build steps. Then We have a new environment created and the application deployed to a new environment in Azure. We have no idea what the fully qualified domain name is. So we run a little bit of PowerShell to get it. And then we download the acceptance test package, and then we run the tests. And the tests are funneled in the URL of the application that was just created that we then asked Azure for. All right. So that is a lot of information. As we come back here, I want to remind you that while TeamCity is an amazing build tool, when you use it in this DevOps architecture, so much more power is unleashed, because now you are orchestrating basically a factory floor of inputs of code changes and then outputs new releases into production. And you have an assembly line that is absolutely visible and you can see what's happening and you have complete traceability. So actually, if I show one other thing, and then we'll close out, how important it is from beginning to end. We have, let me just go to the last build and chains, and we can see, all right, this guy. Yeah, we'll just show this guy. Actually, no, I like this. Sometimes I like this view a little bit better. Okay. This was, yeah, 186. Okay. So we have 3.0.186. Well, let me go to Octopus deploy. And oh, look, off the main branch, I did have 184, but look, I have 3.0.186, and I've deployed it to TDD environment. This is when. I deployed it to UAT. This is when. And I deployed it to production. This is when. Now, if I go to my application in production, well, I've got a hidden URL that our automation uses to make sure /version. And guess what? I can ask the application itself, what version are you? And this just uses the version stamp that's stamped into the assembly of the .NET assemblies that were deployed. So with this DevOps architecture, I have complete traceability all the way through, and I know what's happening. And I know which builds came off the master or main branch and which builds came off of a feature branch. So this DevOps architecture unleashes the already tremendous power of TeamCity as a build server. All right, as we close out, we implement this all the time for customers that are just trying to get into this environment. If you already have TeamCity implemented, or the start of a DevOps environment implemented, and you know it needs to be better, we also do a lot of inspections, a lot of DevOps inspections. And we look at every step comprehensively and identify what needs to be tweaked, identify the good parts that need to stay and are awesome, and help you bridge the gap between where you are now to a complete DevOps environment for a particular piece of software. So that's something that we can help with if it is helpful. And I think I was able to answer some questions in line without having to pause, but I know this is a lot of information. I appreciate your time. Send me an email if you want some of the resources that I showed, and keep an eye out for the next webinars that we have coming up. And thank you so much.